Hi Year 11, welcome to this weekly review video. So there's a few questions, exam style questions to do with trigonometry. Okay, so you're going to stop the video, have a go at the questions yourself, then run the video, check your answers so you can mark your own work, and then you will send a picture of your working out in the task on Firefly, please. Okay, so stop the video, have a go at this question. Okay, pretty easy. I think this first one says EF. EF is a vertical flagpole. Okay, two ropes AF and BF keep the flagpole in position. Okay, AF is 18 meters and AE is 12 meters. Calculate the height of the flagpole. Well, don't get too clever here. That's a right angled triangle. We know two sides. It's a Pythagoras question. We can say 12 squared plus x squared equals 18 squared. So x squared equals 18 squared minus 12 squared. So let's just use your calculator there. 18 squared minus 12 squared equals 180. So we need the square root of 180. Root 180 is 13.4 meters to three significant figures. Okay, calculate the size of angle FAE. FAE. Now that's a trigonometry question. FAE. So this angle here. So we've got to decide, we've got to name everything. So 18 is the hypotenuse, 12 is the adjacent, so it's going to be a cosine. Cosine of my angle is equal to the adjacent over the hypotenuse. SOHCAHTOA tells me that. Okay, cosine of my angle is equal to 12 over 18. So in your calculator, you're going to say shift cosine of 12 over 18. I'm just going to do that now. Make sure you've got your calculator in the right setting. And you're going to get 48.2 degrees to one decimal place. Okay, let's check our answers are right. There we go, 13.4 for part 1 and 48.2 for part 2. Okay. Right, here's the next part of the question. Okay. Angle FAE is equal to 2 lots of angle FBE. Show that BE is 30 meters. Okay, 30.0 meters, so that's this distance here. Okay, stop the video and have a go. Okay, so hopefully you've done that. What we already knew this angle here from the last question was 48.2 degrees. And what we know is that that is twice this angle here. So this must be 24.1 degrees, this angle. And we also know that this distance is 13.4. So we've got to show that this distance was 30. So at the moment, we've got to pretend we don't know what it is. Let's call it x. Okay? So again, it's a trig question. We need to label the sides. We've got opposite here from the angle and adjacent here from the angle. So it's a tan. Tan of your angle equals to your opposite over your adjacent. So the tan of 24.1 degrees is equal to your opposite 13.4 over your adjacent. So x is equal to tan. No, it's not. It's equal to 13.4 over tan 24.1. If you're still not sure how to get to that, then you better ask me, okay? So now use a calculator. So 13.4 divided by tan of 24.1, and we get 29.95, so that is 30.023 significant figures. Okay, hope that makes sense. Let me know if there's anything you're not sure about. Okay, there's your working out there. That's what the mark scheme says. Okay, what about this question? This is a good question. It's combining your knowledge of trigonometry and algebraic fractions. Okay, stop the video and have a go. Okay, so this is a slightly different version of the question here. We're saying find the value of y when tan of your angle is equal to a third. Well, what does tan of your angle equal? It equals the opposite over the adjacent. So the tan of your angle is equal to your opposite 2y, this one's the opposite, this one's the adjacent, 2y over y plus 1. And what we're saying is tan theta is equal to a third. So that must mean a third equals 2y over y plus 1. Okay? So now we've got an algebraic fraction to solve. It should be pretty easy. All I have to do is shove this over here and this over here. So y plus 1 times 1, well, I don't need the times 1, is equal to 6y. So now we can minus y from both sides. 1 is equal to 5y, so y is equal to a fifth. And there's my answer. Okay, y is equal to a fifth. All exam questions, these. So it's a lovely question, that, because that's combining the work we've done for the last few weeks. Okay, what about this one? Stop your video and have a go. Okay, in the diagram, ABCD is a rectangle. Well, that tells me these angles are right angles, which is nice. I've got a bunch of right angle triangles to deal with here. Find the distance PS. PS. Well, actually, what I can tell from everything here, I've got AS is 12. So simple Pythagoras can tell me that PS squared is equal to 12 squared plus 16 squared. Okay, so let's do that. 12 squared plus 16 squared equals 400. So the square root of 400 is 20. So PS is equal to 20 meters. Find the angle BRS. BRS. This is the angle I want to know. This angle here. Okay? Very simple. Let's label some sides. I've got an adjacent, that 24, and I've got an opposite, that's 18. So it's a tan. Tan of your angle is equal to your opposite over your adjacent. I'm writing down those formulas again. So tan of your angle is equal to 18 over 24. Theta is equal to tan to the minus 1 of 18 over 24. So in your calculator, you're going to do shift tan 18 divided by 24. And so the answer is 36.9 degrees. Okay, let's check some answers. There we go, we got them right. Okay, stop your video and have a go. Okay, so it says the angle of elevation from a rowboat to the top of a lighthouse 25 metres above sea level is 6 degrees. Calculate the horizontal distance from the boat to the lighthouse. Very easy if you draw a picture, okay? Here is your rowing boat. Okay, here is your lighthouse. The lighthouse is 25 metres above sea level. 25 metres. The angle of elevation from the rowboat to the top of the lighthouse is 6 degrees. We want to know the horizontal distance from the rowboat to the lighthouse. So that's x. Okay, so let's label some sides. This is the opposite. This is the adjacent. So it's a tan again. Tan of my angle equals my opposite over my adjacent. So tan of 6 degrees is equal to 25 over x. Again, if you're not sure how I do this next step, x is equal to 25 over tan of 6. Let's use a calculator. 25 divided by tan of 6 is equal to 237. Doesn't tell me any level of accuracy, so 238 meters to 3 significant figures. Okay? And think about, does that answer seem reasonable? Yes, it does seem reasonable to me, because that angle is really, really small. It means we're probably quite far away. Okay? Much more than the 25 meters. Okay, what about this one? Here you've got a picture already. Okay? So that should help. So stop your video and have a go. Okay, from a vertical cliff 80 metres above sea level, a whale is observed at an angle of depression of 6 degrees. Find the distance between the observer at the top of the cliff and the whale. So what we want to know is this distance here. Okay, how far is it from here to here? And we've been told the angle of depression. Remember, that is the angle of depression, not this angle. But it now means we can work out that this angle must be 84 degrees. So I've got adjacent and I've got hypotenuse. So it's a cosine. Cosine of my angle equals adjacent over hypotenuse. Cosine of 84 is equal to my adjacent, which is 80, over my hypotenuse, which is x. So x equals 80 over cos 84. We should be expecting an answer that's bigger than 80, because otherwise it wouldn't make sense. Putting that into my calculator, I am getting 765 meters to 3 significant figures. Okay? And I would expect that, because this angle is really, 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 really big. Okay, so that whale is quite far away. Okay, last one. Stop your video and have a go. Okay, a model helicopter takes off from the horizontal ground with a constant vertical speed of 5 meters per second. After 10 seconds, the angle of elevation from Sam to the helicopter is 62 degrees. Given that Sam is 1.8 meters tall, how far is Sam's head from the helicopter at this time? Okay. Now, we've got to be really, really careful here. We've got to work out how high did the helicopter travel. Well, we're doing a constant vertical speed of 5 meters per second and 10 seconds, okay, for 10 seconds. So speed equals distance over time. So distance equals speed times time. So the distance travelled is, speed is 5, time is 10, 50 meters. That means this entire distance is 50 meters. But Sam is 1.8 meters tall. So actually the distance from here to here is only 48.8 meters. I'll just write that here, 48.8 meters. That's this distance to this distance, okay, from Sam's head, the vertical distance from Sam's head to where the helicopter is, okay. So how far is Sam's head from the helicopter? Well, that's that distance there, isn't it? Okay, so we've got an opposite and we've got a hypotenuse. So it's a sine. Sine of your angle is equal to opposite over hypotenuse. Okay, and we're using this right angle triangle. So it's going to be sine of 62 is equal to opposite 48.8 over the hypotenuse x. So x is equal to 48.8 over sine 62. We're looking for an answer that's at least bigger than 48.8. And I'm getting 55.3 meters to 3 significant figures. Okay, so please submit your work on Firefly, and if you've got any questions, any problems that you don't understand, then just let me know.